everyone, welcome back to my channel, and today I'm going to be talking about matrix solutions to system of linear equations, and this is the second part. Now, in our previous video, we talked about the generalizations and derivations required in order to solve any systems of linear equations using the matrix method. Now in this video, we're going to be doing the same thing, except we're going to be trying to demonstrate two main things. Number one, we're going to be trying to demonstrate how to solve the system of linear equations. And number two, we're going to be demonstrating the efficiency of how to solve any system of linear equations using the matrix method rather than using elimination substitution. Now, they can also be equivalently good, but the matrix method, in our point of view, is also really good as well. So let's begin with the first problem. So we have 2x plus 3y is equivalent to 7, and we have 5x minus 4y is equivalent to 12. Before we go into how to solve this practically, let's talk about the general structure. Now, if you want to learn more about the general structure of how to solve any system of linear equations using the matrix method, please visit my previous video. But in this video right now, what we're going to be doing is just talking about the general structure on a higher level. So we're going to be transferring the system of linear equations to A times B is equivalent to C, where B is equivalent to A inverse times C. Okay, so let's use this method and apply it. Now, the main goals that we're trying to achieve while solving a system of linear equations using the matrix method is, number one, try to find A inverse. Number two, we're going to be trying to find A inverse multiplied by C. And number three, which is not really a question at all, is to just say that we found B. Okay, so let's begin by trying to find A inverse. A inverse is just 1 over the determinant of A multiplied by the adjoint of A. Okay, so this is what we're trying to find first. So let's try to find A inverse. But before that, let's just write this system of linear equations in the general form. So the coefficient matrix, which is going to be A, is just 2, 3, 5, negative 4. Then we have the variable matrix, which is X and Y. And last but not least, we're going to set this equivalent to the constant matrix, 7 and 12. Okay, so let's just find A inverse. The determinant is just 2 times negative 4, which is negative A, so negative 8, that's negative 8, minus 3 times 5, which is 15. This is equivalent to negative 23. So we've got so far negative 1 over 23. So we have to find this. The adjoint, there is a specific thing about the adjoint that we already talked about in our previous video, but if you want to learn more about this, we're just going to be talking about a quick shortcut about how to find the adjoint for a 2 by 2 matrix. Notice that the shortcut is only for a 2 by 2 matrix. So we swap the order of the numbers on the principal diagonal. So we get negative 4 and 2, and then we negate these numbers. So negative 3, negative 5. Boom. So we got negative 4, negative 3, negative 5, and then 2. Okay, now that we've got that, we're going to be multiplying these together so we get A inverse. Now, some people might be intimidated by the fact that they see a big number, 23, times these small numbers, and they might end up adding or multiplying very big numbers. But the thing is that many people might stop at this step over here because they see 23 and they realize, oh no, 23 is a big number. And what if I have to simplify it? The truth is two things. One, after you get past this step, it's going to be really easy, and this step is not even that hard. And two, 23 is a prime number, so you really don't have to simplify. So what we're going to be doing is we're just going to be multiplying it. So we get the matrix to be 4 over 23, 3 over 23, 5 over 23, and negative 2 over 23, where the first three elements are positive due to the fact that negative times negative is positive. Okay, so we'll write that over here. So first step is achieved. So A inverse is just 4 over 23, 3 over 23, 5 over 23, and negative 2 over 23. And we have to multiply this by C. So rewriting it once more, 4 over 23, 3 over 23, 5 over 23, and negative 2 over 23, all multiplied by 7 and 12. Now when we multiply this, we get 4 over 23 times 7 is going to be 28 over 23. We're going to add that to 3 over 23 times 12, which is 36 over 23. And 5 times 7, which is 35 over 23, plus, well, 5 times 7 is 35, but we have the denominator. So 35 over 23, plus negative 2 times 12, it's going to be negative 24 over 23. Okay, so let's erase these over here. And let's simplify. So we have officially 28 over 23 plus 36 over 23. So 28 plus 20 plus 36. That's 8 plus 6 is 14. 2 plus 3 is 5 plus 1 is 6. So 64. 64 over 23. Next, we have 35 minus 24, which is going to be 11. So 11 over 23. So we've got this, and last but not least, we have found B as well. These are going to be our two solutions to these system of linear equations, where this is x and this is y. So we officially solved it, but we have to check it in order to validate that these solutions actually fit the equations. So let's erase our work over here, and let's actually check it. So plugging it into the first equation, we have 2 times 64, which is 128 over 23, plus 3 times 11, which is going to be 33 over 23, equals 7 over 23. Well, not 7 over 23. This is equivalent to 7 times 23 over 23. Now the reason we're writing in this way will seem a lot familiar after we just add these two together. So 128 plus 33. That's 8 plus 3 is 11. 2 plus 3 is 5 plus 1 is 6. And 1 is 1. So we have 161 over 23. Now 7 times 23. 3 times 7 is 21. 2 times 14. 2 times 7 is 14. 14 was 216. So that's 161. And indeed, 161 over 23 is equivalent to 161 over 23. And we have checked that the first equation is indeed satisfied by these two solutions. Okay. Now, let us go to the second equation. 5x minus 4y is equivalent to 12. Well, we have to multiply 64 times 5 to get 4 times 5 is 20, 6 times 30, 320. So we have 320 over 23 minus 4 times 11, which is just 44. 423 is equivalent to 12 times 23 over 23. Okay, so 320 minus 44 is just going to be 10 minus 4 is 6, 2 is 1, 1 is 11, 11 minus 4 is 7, 3 is just going to be 276, because 276 plus 4 is 280, 80 plus 20 is just going to be 300, and 300 plus 20 is just going to be 320. Okay, so it's 276. So we got 276 over 23 is equivalent to 12 times 23 over 23. Well, 23 times 12 we're just going to be 3 times 2 is 6, 2 times 2 is 4, 0, 1 times 3 is 3, 1 times 2 is 2, and we get 6, 7, 2, 276, boom. Second equation is also satisfied, and hence these are the solutions to the first system of linear equations, and we have solved this system of linear equations. Okay, now that we've solved the first one, we're going to be speed running the second one as well. Now, we're going to be speed running the second one as well, so it's going to go a little bit faster in calculating the adjoint, determinant, and we're not going to be talking about the general structure. We're just going to be going right into it and giving a brief description. Okay, so 7x plus 4y is equivalent to 9, 9x minus 6y is equivalent to 3. Okay, let's solve it. In 3, 2, 1. So, we have 7, 4, 9, negative 6, x, y, 9, 3. Okay, 7, 4, 9, minus 6, and then x, y, and 9, 3. Okay, so A inverse is just going to be 1 over the determinant, so 7 times negative 6 is negative 42, or determinant of A. Just going to equal to 7 times negative 6 is negative 42, minus 4 times 9 is negative 36. Well, 4 times 9 is positive 36, but we have to subtract. So 42 plus 36 is this, 2 plus 6 is 8, 4 plus 3 is 7, so this is negative 78. So determinant of A is going to be negative 78. Adjoint is equivalent to, we have to swap these, so negative 6, 7, negative 4, negative 9. Boom. Okay, so we've got this. We have to plug this back into A inverse. So negative 1 over 78 times negative 6, negative 4, negative 9, and then 7. Okay, simplifying, we have 6 over 78. We have 4 over 78. We have 9 over 78. And we have negative 7 over 78. Boom. So we've got this over here. So this is going to be A inverse. So we've achieved our first goal. Erasing our work over here, we have to now try to satisfy our second goal, which is to multiply this by C. So A inverse C is what? Well, taking this, we have 6, 78, 4, 78, 9, 78, and negative 7 over 78, multiplied by 9, 3. So this is going to be equivalent to 6 times 9 is how much? 9 times 6 is 54 over 78. 4 times 3 is 12 over 78. 9 times 9 is 81 over 78. And negative 7 times 3 is negative 21 over 78. And we have to add these, and we have to add this as well, but since that's the negative, we're technically subtracting. And let's just check this one more time before we simplify. 6 times 9 is 54. 4 times 3 is 12. 9 times 9 is 81. Negative 7 times 3 is negative 21. Okay, so you got this. So we're going to get essentially 54 plus 12. So that's 50 plus 10 is going to be 60. 60 plus 6 is 66. Okay, 66. 78. And that's going to be 81 minus 21. Well, 60 plus 21 is going to be 81, so that's 60 over 78. Simplifying this furthermore, 66 divided by 2 is going to be 33. 78 divided by 2 is going to be how much? 78 divided by 2. 3. 39. 33 over 39. 60 over 78 is just going to be equivalent to how much? 60 is going to be 30. 30 and 78 is also going to be 39. So we can simplify even further to get 11 over 13 and this to be 10 over 13. Boom. So we got 11 over 13 and 10 over 13 for this. So let's plug it in to check if we got it right. So we got 11 over 13 and 10 over 13, which are also equivalent to B. Okay, plugging in, we got 7 times 11 is 77 over 13. So let's erase this piece of work. And so we have 10 times 4 is 40, so 40 over 13, so plus 40 over 13 is equivalent to 9 times 13 over 13. What is 9 times 13? Well, 13 times 9 is 9 times 3 is 27. 1 times 9 is 9 plus 2 is 11. 117. 117 over 13. Well, 70 plus 40 is 110. 110 plus 7 is 117. So boom, first equation is satisfied. By the way, this is also satisfied, so we can X mark it. Second equation, 9x minus 6y is equivalent to 3. Well, plugging it in, we have 99 over 13 minus 60 over 13, which is easy to simplify. This is going to be equivalent to 33 over 13, which, well, 39 over 13, actually. 39 over 13, which is just going to be equivalent to 3. And so this is also equivalent to this, so therefore we've satisfied this, and we have solved the second system of linear equations. Now, although we speedrun this in comparison to the first one, if we didn't talk about the descriptions and steps necessary to do this, this would have been way more faster and way more efficient. Now, if you just trust a method because it's way more intuitive, because for substitution and elimination, especially for elimination, you have to know what to multiply by, what to cancel, what to take, or to go back again, and you have to kind of remember all these steps. But for this, you don't. When you just calculate this, and you got the determinant for sure, and adjoint there's a specific formula, so you already know this is correct. And for this, you calculate it's a one-time step thing. You got this, and you got your answer. So it's pretty much really easy to solve. So that's why I believe that the matrix method is really good. But it's important to realize that the matrix method also has some flaws. Determinants for higher order matrices can get really complicated. So if you use the same matrix method for an n number of system of linear equations, then it's going to become way more complicated. So that's why this is a pretty good method, because we only have 2 equations in one system of linear equations, and determinants work out properly fine. Now that we've talked about that, we can make this video to an end. If you like this video and if you like this channel, please subscribe to learn more. Thank you.